Pues bueno, muy buenas tardes a todos. Ya vamos a ir a inicio a nuestra conferencia magistral. Espero que no tengan problemas con el traductor, es que hay traducción simultánea. Vamos a dar inicio a nuestra plática denominada Uso y aplicación de la madera para pérgolas y pisos de madera para exteriores. Vamos a tener el honor de presentar a Bosch, al señor Bosch Bernard de Westerwood Preserves Institute. Y quiero comentarles y quiero darles otra vez más una calurosa bienvenida, Bosch. Bienvenido, Bosch. Siempre serás bienvenido aquí a México. Aquí te recibiremos. Quiero que sepas que el Consejo Nacional de la Madera de Construcción aquí en México es el único bastión que promueve cursos de madera para diseño y construcción con madera. En ningún otro lado los proveen más que nosotros, entonces creo que podemos ir adelante y agradezco infinitamente tu apoyo. Gracias, Bosch. Te voy a presentar, voy a mencionar tu semblanza curricular, ¿sí? Bosch Bernhardt es el director senior de programas de Westerwood Research Institute. Es responsable de la educación sobre productos, publicaciones técnicas y normas. Ellos le llaman estándares, normas, aprendizaje a distancia y herramientas de diseño digital para productos de madera preservada. Bernard tiene una amplia experiencia en la producción de madera y asistencia técnica. Brinda soporte de productos, educación del usuario y desarrollo del mercado industrial. Durante más de 3 décadas, en puestos en Western Preserve Wood Industry, Western Wood Products Association, Software Export Council y Western Red Cedar Lumber Association. Tiene una licenciatura en Oregon State University y es la tercera generación de su familia que trabaja en la industria de productos de madera. Tomen nota que ellos están involucrados totalmente en la industria de madera. Western Preserve Institute, con sede en Vancouver, representa a productores de productos de madera tratados con preservadores, fabricantes de productos químicos y otros que prestan servicios a la industria en todo el oeste de América del Norte. Durante más de 70 años, Western Products Institute ha proporcionado servicios regulatorios y divulgación de mercado, destinados a mantener una industria viable de la madera preservada en el oeste de América del Norte. Las actividades de apoyo a los productos de Westerwood Preserves Institute incluyen recursos en línea para productos de madera tratados con preservantes y retardadores de fuego en 3 sitios web. Les voy a mandar su CV, si me permiten, a todos, pues, para que un momento consulten dónde está. Uno es preserwood.org, otro es woodpols.org y Fire Resistance.org. Estos se los voy a mandar, como puedo, los voy a mencionar más adelante para que lo tengan, ¿no? Ok. Si no se los anotan en el chat. Adelante, vos son todos tuyos. Vamos a recibir con un caluroso aplauso aquí a Bosch. Adelante.
Thank you, Manuel. Thank you for that kind introduction. And I'm grateful to be here today and talk about one of the things close to my heart, which is wood. I'm actually a 3rd generation to work in the wood products industry here in the Pacific Northwest, and so I'm very grateful to have this opportunity to talk about our products and how we can help you understand what we do and how our products are used and what the many benefits of it are. Today, my plan is to provide you with an overview of how preservative treated products are made, specified, and used in construction. And my hope that at the end of this time, you'll have a better understanding of American preserved wood products and how they might be used in your outdoor projects where you need to protect that wood against potential deterioration. Here's some of the topics I'm going to be covering today, and we'll start by looking at the history of preserved wood, how we make it, the manufacturing process, what we use to protect that wood against deteriorations, the standards that guide the application of those preservatives into the wood, and then explore exactly why we use preserved wood in the market today. Let's start with an introduction of preserved wood. Now, as you know, wood is really unmatched as a building material. It's strong, but it's light. It's easy to work with basic tools. It's readily available. It's environmentally friendly and sustainable. And with just a few inputs, wood really provides a variety of benefits, from oxygen and wildlife habitat to resources for building products. Now, it takes here in North America, between 30 and 80 years to grow trees large enough to be harvested and then converted into wood products. Now, with preservative treating, we can extend that wood's natural life from years to decades. And that means that when a preserved wood product is at the end of its useful life, there's been plenty of time to allow a new tree to be grown that can become that replacement product in the future. So sustainability is really a key issue for wood products, and by preservative treating, by making it last much longer in place, we enhance that sustainability. Now, wood is really made to grow, die, and then break down into organic material that kind of starts that process all over. And there are a variety of organisms in nature who have the job of breaking that wood down. Now, that's all well and good when you're in the forest and you have a tree die and you want it to deteriorate and become a new tree. But it's really more of a problem when we've turned that wood into a product and use it in a structure. Now, over the centuries, we've learned to slow that natural deterioration that happens. And we first did it with design. And this picture here of the Stave Church is one of those examples of it. This church is 800 years old, and it's a wood structure. And it's been protected from deterioration by the climate it's in, for one, and secondly, by design that moves water away from the structure, that allows it to stay in place. Now, to make wood last, it needs protection from two types of organisms. The first is decay fungi, or also known as rot. And then the second is wood-destroying insects. That includes termites, borers, and marine worms for wood products that are used in aquatic applications. Now, when it comes to decay fungi, there are really around 100,000 species of fungi in the world, and they're ever present in our environment. The spores from this fungi are in our air. We're likely breathing some of those right now. Now, for decay fungi to break down wood, it really needs four basic things. It needs food, which is the wood, suitable temperatures, moisture, and oxygen. Now, for wood that's going to be used outdoors, it's virtually impossible to control the temperature or the exposure to moisture or the oxygen. And so, to keep decay away, we must change the food source to make it less attractive to these fungi. Now, one of the dangers posed by decay is that it may be difficult to see. This first photo shows the underside of an outdoor deck that's been painted. But if you look below at the infrared scan, it shows that parts of the wood have likely decayed. And this has probably happened before the paint was applied. Now, over time, this decay is still, if there's moisture still available there, it could significantly impact the load carrying capacity of the underside of this deck and create safety issues for those that might be standing on top of it. Now, when you place wood in near or in the ground, you also have very high risk for decay, as the moisture from the ground or nearby vegetation can provide a quick route for decay fungi to move to the wood and begin that deterioration process. Now, insects pose another risk to exposed wood. Now, these insects do serve an important purpose in breaking down the wood, and they actively search throughout nature for this dead wood, even if it's been converted into a product. That doesn't seem to change their minds. Whether it's a dead tree limb or wood in a structure, these insects still look for that as food. And if they do start impacting a structure, they can create significant damage. Here in the United States, wood-destroying insects can cause an estimated $5 billion worth of damage to wood products used in this country. So they're very much prevalent, very much out there, and just underscore the need to protect that wood when you do have it in exposed conditions. Now, the best way to protect wood from such threats is to change it so it's no longer desirable as a food source. And we use wood's unique characteristics to create a protective shell around the wood using preservatives. Now, this protection is not only on the surface of the wood, it's moved deep into the wood fiber, and again, using the structures that come with wood. Now, under pressure, we create a barrier within the wood to protect it, while at the same time we can retain its workability and its strength characteristics as a wood product. So how do we add this protection? Let's take a quick look at the treating process. Now, efforts to protect wood against deterioration are as old as civilization. There are records dating back to ancient Greece and Rome about preserving wood. The first commercial pressure treating really began in the mid-1800s. At first as a way to protect timbers in sailing ships, and then later it was soon used for a variety of other infrastructure applications: rail ties, utility poles, bridges, and marine pilings. The first standards for pressure treating were published in 1904. And throughout the 20th century, the process of treating and the development of different preservatives evolved into an industry that today produces millions of cubic meters of preserved wood, ranging from sawn lumber and timbers to plywood to utility poles and pilings. Treating is really a fairly simple and straightforward process. Here in the United States, there are 3 species that are typically pressure treated. Those are Douglas fir and hem fir, which grows in the Pacific Northwest, the western states, and then southern yellow pine in the southern United States. Southern pine is treats very well. It accepts treatment very well. So there's a significant volume of southern yellow pine that is pressure treated. Douglas fir and hem fir are smaller in terms of volume, but have unique characteristics of their own for use in outdoor applications. Now, treating companies purchase the lumber, timber, and plywood from sawmills and plywood plants. And then those are shipped to the treating plant. And then once they arrive, the products are then maybe sorted and trimmed for whatever the final product's going to be after treatment. Now, many treaters in the western United States stain the lumber prior to treatment to create a consistent color. That you also starting to see this in the South as well. And then for Western species that are intended to be used in ground to contact applications where they're at or in the ground, those products are going to be incised, where a series of slits are cut into the wood to provide a pathway for the preservative to reach deep enough to provide the necessary protection. Southern pine, by comparison, does not need to be incised because, again, it's the way that fiber structure works. It really takes in preservative and naturally can get deeper into it without any additional assistance, like what you see with Western species. Now, once that wood is prepared, it is then put on carts, and then it's moved into a pressure cylinder, which is called a retort. And that can be up to 43 meters in length. Then once the wood is inside, the retort is sealed, and a vacuum is applied to remove the air and prepare the wood cells for the preservative. Then liquid preservative is pumped into the retort, and it's mixed with either water or an oil-based solution, and then it's filled, and the retort is completely filled. Then pressure is applied over time to move the preservative into the wood cells, and the amount of time and the pressure used really depends on the species, the size, and the level of protection that might be desired. Now, when the treating cycle ends, the preservative is drained from the retort, and then the wood is rolled out onto a drip pad where any excess preservative that may remain on the surface of the wood can be collected and then used again for future treating. For quality control, core samples are taken from the wood and they're analyzed to ensure that the proper amount of preservative is in that wood and that it's reached deep enough to meet industry standards for that. There's also third-party inspectors who come through those plants and take cores of their own to confirm the plant's quality control. Then once the products have finished the treating cycle, they're going to be moved to a storage area and be ready for shipping. They'll usually add a top wrap to protect it against any moisture during transit. And then it's ready to travel to the final destination by either truck, train car, or by barge. So now that we've made this wood, what do we do with it, and how do we use it today? Well, there are really a variety of preservatives that are used today to make it durable. And all of these preservatives that we use are approved and registered by the United States Environmental Protection Agency, or EPA. Now, each of the preservatives that are available in the market today have an extensive proven record of performance, and there are national consensus standards that guide their use in treating and in the use of the products. Now, the active ingredients in today's preservatives can also be found in many other products that we use in everyday life. One of the main ingredients is soluble copper. Now, copper is a very effective deterrent against insects and decay. And so soluble copper is often added with found in waterborne preservatives that are used in typical outdoor construction in residential and commercial applications. The other ingredients that are found in preservatives include biocides and fungicides, which are the same chemicals that you can find in consumer products. These include azoles, which is a biocide that is used to protect food, flowers, and agricultural products. Quaternary compounds are found in disinfectants and household cleaning products. So these are, and then borates are another one that you can find in consumer products such as eye drops. And again, these are indeed chemicals. However, they're very safe chemicals, and we use them in many other applications. Now, the treating and the use of preservatives are guided by national standards that are published by the American Wood Protection Association, or AWPA. And all of these standards are defined in the AWPA Book of Standards. And the Book of Standards really establishes the retentions, or the amount of preservative that should be in the wood, and then the penetration requirements for each preservative based on its intended use. In the United States, the building codes reference the AWPA standards and the use categories that are defined within the book to make sure that the proper products are specified to meet the conditions where the wood is going to be used. So as I mentioned earlier, there are really two basic types of preservative based on what is used to carry the preservative into the wood. Waterborne preservatives are mixed with water to carry them into the wood. And again, they're found in many products that are used in residential and commercial construction that are exposed to the weather. Oil-type preservatives are dissolved in petroleum products, mineral oils, and some of the new biodiesels that are available for treating. Oil-type preservatives are really suited for more demanding conditions and are typically found in infrastructure applications, things like utility poles, rail ties, and marine pilings. Let's first take a look at the waterborne preservatives that are commonly used today. Here you'll see the main waterborne preservatives, and they're mostly known by their acronyms. The first of the four copper-based preservatives are ACQ, ACZA, CAC or MCA, and CCA. And probably the most common that we see used for waterborne preservatives in the market today is CAC, copper azole, or MCA, and which is micronized copper azole. And the chief difference between CAC and MCA is that MCA has a much smaller copper particle compared to copper azole. And so as a result, micronized copper azole, MCA, is used predominantly in southern pine, whereas CAC, which has a larger copper particle, is used in western species such as Douglas fir and hem-fir. And it just, again, it has to do with the fiber structure of the wood and the different species. And so it's rare that you would find MCA in a western, in a Douglas fir or hem-fir product. However, CAC has the exact same protective qualities as MCA from a performance standpoint. CCA, also on the list, really was the dominant preservative for many decades. But back in 2004, the industry voluntarily removed it from use in residential applications. And part of that was some concerns about the A in CCA, which is arsenate, a form of arsenic. You know, there were never any health issues found from exposure to CCA treated wood. However, out of abundance of caution, the industry moved that to other applications. And so today we continue to use CCA, and it's used mostly for utility poles, southern pine utility poles, agricultural posts, and road guardrail posts. Next on the list is our borates, which are also known by the acronyms SBX and DOT. Borates are a natural mineral, and their use is really limited to applications where the wood is not going to be exposed to liquid water, but still requires protection against insects. Borate treated wood is most often used here in the United States as sill plates, which is that first board on a wood frame structure that goes down on a concrete slab or a concrete footing. And that provides some protection from some of the moisture that might come as the concrete is drying. But it's also the exterior is constructed and protects it against liquid water. You also see borate treated framing lumber used in termite-prone areas because borate is an effective deterrent against termites, and so we see it. Building codes in Hawaii require treated framing, and borate is most often the treatment that is used for that. Southern California, and then you move into Mexico as well, there, where you have a high risk from termite infestation. That's where a borate would be the best. The newest formulations are what are called carbon-based preservatives, and they use hardly any metals at all, like copper, and instead they utilize biocides to provide that protection. They are very effective. However, those preservatives are only able to be used in above ground applications, and they're not really available and have not been rated to be used in ground contact applications. Now, you can find an overview of the waterborne preservatives in this publication that's available on our website at preservedwood.org. Also in our technical library, we offer a number of Spanish language titles to help you in specifying and using preserved wood. Now, let's take a quick look at all of these preservatives and look at the brand names that they may be sold under and how they're typically used. ACQ has been around for many decades, but it's really in short supply today. The Q stands for quaternary, which is a disinfectant, very effective biocide against various organisms. And so, particularly in the last couple of years with our pandemic, a lot of the quaternaries have been moved to using disinfectants and not been available for wood preservatives. And so that means there's less of this important ingredient as part of this preservative. And so many of the producers who were treating with ACQ have moved away to other preservatives. ACZA has been around for a number of decades. It started in the 1930s, and you'll often find it promoted under the brand name of Chemonite. ACZA treated wood is often used near aquatic environments where it'll be exposed to water. The AN is ammonia, and part of that ammonia is in there to allow it to better bond with the wood. It's more a part of the treating process, whereas the zinc and copper and other components really provide that protection. Again, copper azole, CAC, and MCA are the most popular and most widely available waterborne preservatives. And as I noted earlier, the only difference is in the size of the copper particle. Again, both have very, very similar performance. CCA, again, we've seen CCA, while you can't necessarily buy it in the US for decking in homes, it is still very widely used in infrastructure and agricultural applications. Borates, again, sill plates, framing, and really in high risk areas where you have a risk from termites. And the copper-based preservatives, they're often promoted under names like PTI and EL2. Since they don't use metals, there's no issues with fasteners, which we'll touch on soon, and they're really promoted for safety. Some of these have earned accreditation from National Green Building Standards and for low levels of potential chemicals that could impact the environment. But again, these products are not available for ground contact. Oil type preservatives, I'll just touch on these because, again, most of these are for really demanding conditions, and they're used for mostly infrastructure applications where they may be in the ground or near the ground or in and around water. Among these is copper naphthenate or QNAP, and it's used in a variety of products from rail ties to utility poles. Creosote was the original preservative that was created, found about 180 years ago to be very, very effective, and it comes from coal tar, distilled from coal tar, and it's used almost exclusively today for rail ties. Penta is used for utility poles and wood bridges, but it's slowly being phased out. The sole manufacturer, which had a plant in Mexico, closed that plant late last year, and so it's slowly, as current supplies are drawn down, we'll see less and less Penta available. The EPA has changed the registration on it, and so there's a 5-year phase out going on for it that started this year. DCOI is the newest oil type preservative, and it's really looking to take over for Penta for those applications. Again, mostly utility poles, timber bridges, and the like. IPBC is found in specialty products such as glulam. The carrier on that is usually mineral oil, and so it's but it's also used because it does tend to penetrate well for Douglas fir. We see it mostly used not in wide open outdoor exposures, but in high humidity areas. Okay, so now I'm going to talk about the preservatives. Let's talk about use category system, because that's really what drives what we put in the wood, how much we put into it, and how deep it should go, and then how we're going to use that product at the very end. So the use categories were developed prior to the use categories in the early 2000s. Treating was based on commodities. There were commodity standards or C standards. Use categories were developed because they were a simpler way to do it, and they're based on the risk of deterioration in its intended use. So all of the preserved wood uses can be placed in one of 5 use categories that describe those conditions of where they'll be used. And within each use category, there are subcategories within that for defined degrees of protection. Simplicity is really the advantage of use categories. The higher the number, the greater the risk to the wood from deterioration. So UC1 and UC2 are the least demanding conditions, most often in interiors where they can protect against insects and have little moisture that might be a part of that. UC5, the top end of it, is for the most demanding conditions, which is basically marine pilings where the wood is constantly exposed to water, marine borers, and because of tidal, may be exposed to water and then dry, exposed to water and dry on a regular cycle on that. So let's take a look at each of these. Again, UC1, UC2 are very similar, and they're really separated only by the potential level of moisture. UC1 is really for dry interiors where insects are the main risk, or the highest risk. UC2 is really for applications where there may be dampness, and this includes the sill plates where there may be moisture from the concrete drying. And again, for framing in termite-prone areas. UC3 is your above-ground use category, and there's 2 subcategories within that. UC3A is for wood that's typically used in outdoor exposures and that's regularly exposed to weather, but they're protected in a way that allows water to drain quickly from it in such applications such as vertical walls. A UC3B is what you'll find mostly in the marketplace for an above ground treated product. This is wood that's treated to take on all weather exposures, but are located above the ground so that the water, any moisture that does fall on it, has an opportunity to dry naturally. Decks, deck joists and beams and fence pickets are really the products that are most commonly treated to UC3B. A UC4 is really your ground contact category, and it's traditionally been used for ground contact, and in fact, under the description, it's called ground contact. But a few years ago, the standards were broadened to include applications where you may have the same risks as a ground contact, but aren't actually in contact with the ground. And so these include wood that might be difficult to replace or repair, or applications where the wood is exposed regularly to water, both naturally and artificially, such as recurring wetting from a sprinkler. So within this category, there are three different subcategories. UC4A is what we typically see for things such as deck framing, posts, timbers, and other structural products. UC4B is it's considered heavy duty applications in ground context. So that might include building posts, utility poles, and piers that might be above the water line but still have some exposure to moisture. And then UC4C is the highest level. UC5 is the highest category, and it's really for in-water uses such as docks and piers. And within there are three subcategories, A, B, and C, and those really reflect where the wood is being used because the marine bores are different. So, for example, UC5A, UC5A is in colder northern waters above San Francisco on the west coast and above New York on the east coast. 5B are for oceans that are south of that, and 5C are for the Gulf Coast, where you have the warmest waters and things like Puerto Rico as well as Hawaii. And again, the only difference is that those your threats are different because the marine bores are different based on the water conditions and the warmth of the water, the ocean water in those applications. We have prepared an infographic that really goes through, particularly for residential, that talks about the typical use categories for various applications that you find in residential construction. This is available on our website in Spanish language, so I encourage you to check that out. All right, let's next review some important information to know when using preserved wood in construction. And this is an area that I was asked to really focus on, to talk about some best practices to make sure you have the best possible experience and have the right product for the right condition for those applications. Now, because we're using preservative treated wood outdoors, it really poses some unique challenges because of the significant threats to the performance, as we mentioned. And nature has a way of breaking those down, and we really can't control those elements. We can't control the weather, and so we really want to look at how we can best do that, not only in the product, but in how we use that product when we go into construction. Now, we really, when we cut this wood, it doesn't really change the fact that there's still things out there that want to break it down. And so termites and rot, really take apart the cell structure of wood. And that's where the strength of wood is. And that's where you end up with some real issues when you're using it in a structural application. And we've seen too many instances where the conditions have created issues that wood has deteriorated many times unnoticed, and it has created significant injuries, as well as even deaths. And oftentimes this damage happens unseen, and it may be cases where the moisture has been exposed. It's been exposed to moisture. That moisture is trapped. Decay sets in, or insects and the like. So really the longevity and performance of the wood, using the right preserved wood product is the first step in it. But there are a number of other things that you can do that can enhance that performance. Now, we do have a publication, a Spanish language publication, that goes through all of the use categories with fuller descriptions on that. It has some basic information on the preservatives, as we talked about. And really, you want to, I encourage you to get that from our website to use in guiding that you're going to choose the right product for the right application. And one way, once it's been treated, and you're specifying a product, you want to make sure that's the right product. And for products that are sold in retail applications, and that are used in building code, where they're guided by building codes, the end tag has all the information that you need to identify that product and know exactly if it has the proper level of protection, if it's treated to that use category for where your project's going to be used. Now, the end tags are going to differ in appearance, but they all have the exact same elements, and those elements are defined in the U.S. Building Code under section 2304.11. And these tags, they're stapled on the end of the piece, provide all the information that you need to identify the product when you're at the job site, to make sure it's the right product that you've selected for it. So that information includes the exposure condition, above ground, ground contact, the use category. In this example, UC3B, which is the above ground, and then the standard on which it was treated to, which is AWPA U1. It has the amount of preservative, or the retention, in pounds per cubic feet, the PCF. It has the name of the preservative, and also includes the identification information of the treating plant, and then the logo of the third-party inspection agency that confirms that the wood has been produced under the quality control and meets the standards. The check mark that you see there is one that indicates that the wood has been produced in accordance with AWPA standards. My organization, WWPI, maintains that check mark, and we've created that a number of years ago to help building officials look quickly and know that that product is going to perform according to industry standards. Now, as I mentioned earlier, pressure treatment is really a shell treatment, where the outer layer is protected by preservative. And again, that's because the structure of wood fiber and its natural openings really make it difficult to deeply penetrate all the way through the wood. And that's particularly true in Western species such as Douglas fir. If you look at a piece of wood, and a wood has sapwood, which is the outer layers where those wood fibers carry nutrients and water up and down the tree when it's alive. Then you have heartwood, where as a tree grows up, that heartwood provides the structure changes a bit. Actually, a lot of the holes and places you can move preservative in it close off. So it's very difficult to, if not impossible, to treat heartwood. We're treating the sapwood when we treat products. And so with Western species, they're a difficult species to treat. That's why we use things like incising. Southern pine, by comparison, Southern pine, you may have natural penetration of as much of an inch into the wood, whereas in Western species, it's about 4/10 of an inch. Again, we've done the studies that indicate that 4/10 of an inch for Western species does provide the necessary protection. Now, when you're going to be using preserved wood, you're going to be cutting it and drilling it as part of the construction process. And as a result, you tend to open up areas of wood that's untreated that will, if impacted by insects or decay, can begin to deteriorate. And so under building codes and under standards, American standards, we have to do a process called field treating. Now, field treating basically creates a coating on the ends and in the holes that provides protection of that untreated wood. Now, even though that's not necessarily been pressure treated, because those are typically vertical places where those cuts and where that product's going to eventually be, where there's no little chance of water pooling. The field treating is incredibly effective in protecting that wood, and it really requires just using a field treatment that contains either copper naphthenate or oxine copper, and you simply brush that on or use a roller. And it's really a critical step that's often neglected when you're working with preservative treated wood in construction. It's relatively easy. You don't need anything special to do it, but doing so really enhances the performance of that product. So I definitely encourage you to include that as part of your construction practices when you're using preservative treated wood in outdoor applications. Fasteners is another area. In fasteners, we're talking about nails, screws, hangers, plates, and other type of metal connectors as part of the project. Now, as I mentioned in the preservative section, the waterborne preservatives used today are essentially contain copper. And so they have fairly high levels of copper, as much as 70 to 90% of the preservative might be soluble copper. Well, the copper in that wood can interact with the metal in a fastener and create a process called galvanic corrosion. Galvanic corrosion. And basically, it's because you have two different atomic weight of metals. Copper is usually higher, and so it's going to be the steel in the fastener that's going to begin to deteriorate. The moisture that's within the wood, because all wood has moisture, becomes the conduit that encourages that corrosion. So the U.S. building codes, international building codes, and industry practices call for fasteners that are high quality, hot dipped galvanized or stainless steel. Those are the most commonly used fasteners when you're working with preserved wood. Silicon, bronze, and copper fasteners can also be used. So it's really, when you talk about galvanic corrosion, I think probably one of the most famous instances of this happening was at the Statue of Liberty in New York. The exterior of the Statue of Liberty is made of copper plates, and it was attached to the supporting frame, which was iron. And then over time, through galvanic corrosion, the insulating layer between the copper plates and the iron began to give away. And by the 1980s, the iron structure became so corroded that it had to be required extensive renovations. So again, this is one of the things that can happen unnoticed. And we really saw a lot of this happening as back in the early 2000s, as we moved through from CCA to these newer formulations. CCA had smaller amounts of copper, so it wasn't as much of an issue as we have today with, again, 70 to 90% of these preservatives have high levels of copper. Another real important area, particularly when you're dealing with things like decks and outdoor structures, is in connecting those to your existing structure and providing something that's going to last. So, like with decks, whether they're residential or commercial structures, if you look at deck failures that we see in the U.S., significant number of those happen and can be traced back to faulty connections between the deck structure itself and the wood structure. Now, decks are typically attached to a house with what's called a ledger board. Now, this board is attached to the house, and and then the joists are connected either through nailing or joist hangers or other types of fasteners, and they provide that chief structure to connect it to the house. And too often, this ledger board is untreated, or it's put into a position where, as that deck is exposed to the weather and moisture, that moisture gets trapped. That trapped moisture begins to encourage the formation of decay fungi and begins to rot away. And so it's really critical that that ledger board is connected properly to the wood structure, and it is a material, a preserved wood product that can basically withstand those conditions. The American Wood Council provides perhaps one of the best resources on properly constructing decks. And their publication, Prescriptive Residential Wood Deck Construction Guide, really provides an in-depth look at properly constructing safe and long-lasting wood decks. 3 years ago, AWC released a Spanish language version of the guide, and it can be downloaded from their website in the address shown on the screen. Now, this guide provides everything you need to know about constructing wood decks and structures, covering the underlying structure, the joists, the posts, ledgers, spans, loading. It even has stair requirements. And it features information on all North American wood species, including pressure-treated and then naturally durable products such as redwood and cedar. And I really encourage you to check this out. It's a very well done guide, and it has some extremely beneficial recommendations to ensure that your project's going to last to what you anticipate. Now, preserved wood really can be handled the same as untreated wood. You know, obviously you should take some common sense precautions. You know, we recommend that you wear gloves and long sleeve shirts just to avoid slivers and in your hands and arms. Certainly wash your hands before eating or smoking or drinking. If you're going to be sawing it, it's a good idea to wear a dust mask to avoid inhaling the sawdust, and wear goggles when you're sawing to protect the eyes. Again, and that's not really unique to preservative treated wood. It's pretty much recommended for all wood products, these common sense measures. Disposal is becoming more and more of an issue, and you want to make sure to dispose properly of any scraps or if you're particularly for remodeling, where you may be removing a preserved wood structure and replacing it with a new one. Here in the United States, all states other than California, you can dispose of preservative treated wood in a regular landfill as you would any other wood, untreated wood. In California, California has some restrictions, and it can only be disposed in composite lined landfills. We recently managed to get some legislation approved through the state legislature that guides, that provides alternative management standards for the disposal of preservative wood, treated wood waste, TWW. And there are links to that site. For most folks, that's not too much of an issue. One of the things in terms of disposal that that are really not recommended, you do not want to burn preservative treated wood in open fires, in stoves, or in fireplaces. That can create the release of some of the preservative in the wood, and be a potential health impact from that. Okay, let me go ahead and close today just by talking a bit about the environmental benefits of preserved wood, and touch on that. Wood offers many more benefits for the environment compared to other materials. It's sustainable. It comes from a renewable resource, and then when we preserve it for demanding conditions, we extend that life, the life of the product, far beyond what it would be if you put it in those outdoor conditions and left it untreated. So, and we can grow a new tree by the time we come to the end of that functional life. Now, really, the benefits of any building material really should be assessed on as an objective process and the science-based approach as possible. And we've done that through a series of internationally recognized life cycle analysis or assessments, or LCAs. Over the past decade, we've commissioned a series of these LCAs that compare preserved wood to alternatives. And these are cradle to grave perspectives. These assessments are done through international standards, and the results have been confirmed through scientific peer review. And as you can see in looking at this chart, in 7 key environmental indicators, wood has significantly lower impacts on the environment. These indicators include greenhouse gas emissions, fossil fuel use, water use, and ecological impact. Now, there are certainly applications where alternative materials may be more appropriate for that specific use. But in instances where a preserved wood product could be used in the same way, the environmental impacts of using that preserved wood product are far less than the alternative. And we as a society, as a world, are becoming more and more cognizant of that, and in the choices we make, in the things that we do, and the materials we use. And so we think that's an important consideration, and we believe that wood has the great potential to be good for our environment compared to the other materials. So that really brings me to the end of my presentation today, and I appreciate your time. I hope you've learned some things about preservative treated wood that can help you in deciding how to use it in the future. These products have been around for more than a century, so we have a long proven history of use in a variety of different applications, and we're confident that these products will continue to be used far into the future. There's just so many benefits that are found in preserved wood products, and we certainly want to make sure that all those that use our products are having the best possible experience in using them, and they meet the expectations. There are a variety of resources available to you online to help you understand preserved wood products. We have a full technical library on our website, and while most of those publications are in English, we do offer a couple guides in Spanish, and including our specification guide that are free to download. And in fact, this entire presentation, we have a Spanish language version that we've just finished up that will soon be available on the Softwood Export Council site, as well as the Mexico office site. And so with that, there are a number of organizations that also provide information. And so appreciate your time today, and I'd be happy to answer any questions that people might have.
Hay unas preguntas ahí en el chat, vos, si quieres verlo.
Sure. Let's see.
Están pidiendo tu ponencia, la puedes compartir, nos puedes enviar la ponencia.
Yes, we can definitely do that. Yeah, I see one of the questions: is there a way to buy the chrome azerol, which is used to proof wood, proof it that CCA is impregnated? Is there a commercial brand? I'm not aware of a commercial brand, but certainly there are. I can look into that and see if there are some suppliers of that. With our inspection agencies, they use a bit different process to look at the type of preservative that might be in a wood, both at the plant and in inspections. And they use an X-ray fluorescence where the cores are ground into dust and then dried, and then they're put into equipment that can check the metals and things. So while the chrome azerol can tell you if it's been treated with CCA, it's not necessarily going to tell you to what level it was treated at. It may only tell you the presence of that. A lot of times you can identify preservative treated wood by its appearance. Particularly CCA treated wood products tend to have a greenish tint to it, again reflecting the copper and zinc in the wood. But at other times that it may be difficult to identify them, and usually the only way you can identify it is through things like core samples, and check through that. Let's see. Do you have a dealer or a partner in Mexico? We are a trade association, so we represent wood treaters in the Western United States. On our website, you'll find a list of our member companies that do produce and sell those products. It's called our sources of supply, and I would encourage you to take a look at that and identify those treating plants nearest you who might, or treating plants that might be providing products into Mexico. Let's see. All right. Here's one from Georgina.
Preguntas.
Let's see. I see one. It's in Spanish. I'm sorry, I don't understand it. Can someone from No, and that's a great point, a great question. One of the things that that's really important to understand is that it's really not possible to get treatment into wood to have it penetrate into the wood without pressure. It's just any type of things like a linseed oil or other types of surface applications really doesn't get that deep into the wood. In fact, hardly at all. And it's because of the nature of the wood structure. Wood kind of protects itself from nature that way, but it also makes it difficult to get things like preservatives into it. So those type of exterior applications do provide a limited level of protection, but that protection is not going to last because it has nothing to really bind into the wood. Preservative treating really pushes that into the wood fiber itself, and it utilizes the natural holes that are in part of the wood fiber to take that in. Preservatives like CCA, for example, also do a process called fixing, where part of the components of CCA, the ingredients in CCA, help bind the copper to the wood fiber deep into the wood to provide that protection. That's not possible without pressure and putting it into a sealed chamber into it. You cannot do it in the field. So any type of application in the field, it may provide some limited protection, but that protection will dissipate over time. And so if you're, we really are starting to see this in fire retardant treatments, where people want to protect against fires in structures, particularly in wildfire areas such as California and the Pacific Northwest. And they're looking and they're thinking that, well, we can just spray something on and that'll work. It really doesn't. It really doesn't. The pressure treating process is a critical part of that, and you cannot do that in the field. And so, protecting that wood with stains and other coatings, again, does provide a limited amount of protection, but certainly not to the same level as you get with preservative treating. Okay, I see another question. Thermo-treated pine. Yeah, thermally treated products. We've seen a number of those over the past 10, 15 years. And basically, thermal treating essentially bakes the sugars in the wood and creates the protection that way. They're pretty good products, but they're not really widely available. And the other drawback with thermally treated products is that the manufacturing process is incredibly energy intensive. And with energy prices the way they are today, it certainly increases the cost of those products. But they are, the thermal treatment does work and is very effective. But some species, it's a little bit more difficult because of what you might have in the structure of the wood. Some species, hemper, for example, hemper naturally has moisture pockets within it that create some issues with drying, and so that's one thing to keep in mind. Most of the thermal treated pine we've seen comes from Europe, and so you've got, again, a different set of species. Next question: what do you suggest for kitchen cutting boards? Preservative treating really is not intended for interior uses. Preservative treating is really intended for outdoor exposures, and so I would not recommend any preservative treated product for use such as kitchen cutting boards and the like. I think a untreated wood would probably provide a much better application for that, and And so I would, again, preservative treating is really to protect against the elements. And, in the kitchen, you don't have a lot of exposure to the elements. So let's see, next question. Can engineered wood be pressure treated? Another great question. Basically it can't be. And one of the reasons why is that, as I mentioned earlier, when we treat wood, we're treating the sapwood, basically the outer layer of a tree, and then the heartwood is very, very difficult to treat because that wood structure has changed. Now, in an engineered wood product such as OSB, OSB is a series of chips. And those chips may come from the middle of the tree, may come from the outside of the tree, and they're all mixed together and then bound with rosin to become a panel. As such, you can't really treat that because you don't have the same structure as you would have in a solid piece of wood. There is some work to look at things like including the protection, the preservative protection within the rosin, but it's still very, very early. There is a company that is selling LVL and other type of engineered wood products using preservatives within the glues. However, those are just now being recognized, and there's really not been a lot of experience on whether that provides the necessary protection. And so I think it's and again, where you're using engineered wood products, your risk level is different. You typically aren't going to use an engineered wood product in a ground contact situation. Usually engineered wood products, I-joist, for example, for a residential structure, you've already protected it against moisture because because of the design of the structure. You don't have liquid water really near it. So in a lot of the cases for engineered wood, it's not necessary to do that. So in the few applications of engineered wood where you would use it and exposed, anything that has an OSB in it would be I'm not sure we're quite there yet in the technology for it, and you may be better off with a conventionally treated solid product to provide that necessary protection. Any other questions? Very well. Well, again, thank you for your time, and encourage you to check with our office in Mexico and at the Softwood Export Council. And again, we have a number of resources there, and you're welcome to reach out to me and our website at preservewood.org, and I'd be happy to assist you in any way we can.
Okay.
Thank you very much, Butch, for your presentation and for your time.
Thank you.
And muchas gracias a todos los que
Soy. Bueno, muchas gracias por tu presentación, Bosch. Una vez más, como siempre, muy buena presentación. Te agradecemos tu disponibilidad. Ya siempre comentarás estar en los cursos de Comaco. Te pedimos por favor que dejes de compartir pantalla para enviarte algo. ¿Lo escucha?
Okay.
Ok. Pues muchas gracias. Ya sabes, serás bienvenido aquí en Comaco siempre a nuestros cursos. Y a nombre de Comaco, nuestro agradecimiento, sincero agradecimiento por tu apoyo. Te vamos a enviar un pequeño reconocimiento. Te dice así.
Thank you.
El diploma lo expide el Consejo Nacional de la Madera de la Construcción. al señor Boris Bernhardt por su brillante participación como ponente en el curso de diseño, construcción e instalación de decks, pisos y pérgolas de madera, celebrado los días 26, 28 de abril y 3 de mayo con una duración de 14 horas. En este caso lo suscribo yo como gerente general del Consejo, Manuel Lorza. Te lo mandamos por correo y muchas gracias por tu presentación, ¿no? Y y una felicitación a ti, un aplauso para vos. Muchas gracias a todos. Mi agradecimiento también a la licenciada Tania Basavilbaso por su apoyo, a SEC, a Software for Council, a Western Port Preserves Institute, también por su apoyo. Muchas gracias. ¿Algo que quieras agregar, Tania?
No, nada más. Muchas gracias también, Manuel, y a todos los que participaron en el webinar. Muchas gracias a todos.
Quedamos en espera de la ponencia de voz que la están pidiendo. Ahí te la encargo, Tania, para reenviarla, por favor.
We can do that.
Ok. Perfecto. Muchas gracias. Pues, saludos. Que pase una estancia muy agradable. Nos vemos. Hasta luego. Gracias a todos. Gracias a los asistentes. Gracias por su paciencia. Disculpen si con la inmediatez a veces no se puede mandar todo tan rápido. Por correo contestamos todo. Gracias. Muy amables. Que pasen bonita tarde.